So today's video is about ratios. So the first thing we'll learn about is what is a ratio. Well, a ratio is a comparison of quantities and numbers. So a ratio compares quantities and numbers. So as an example, we have this picture of 5 children, and if we wanted to make a comparison, we can say that the ratio of girls to boys is that we have 2 girls and 3 boys. So the ratio is 2 to 3. Another comparison we can make is the ratio of girls to the total number of kids. So we have 2 girls and 5 total kids. We can do the ratio of boys to girls, and we know that there are 3 boys and 2 girls. And then another ratio could be the ratio of boys to the total number of kids. So there are 3 boys and then 5 total kids. So in each one of these examples, we were making a comparison of different quantities within this group of children. So that's what a ratio is. It compares quantities and numbers. So how do we write ratios? So there's a couple different ways that we can actually write a ratio. So the first way that we can write a ratio is using a symbol. So we can actually use this symbol here, which is the colon. So of course we'd have our first number, then the colon, and then the second number. Another way that we can write a ratio is in word form by actually using the word to. So we could say that this would be 2 to 3. And then the third way that we can write it is in fraction form. But even though it's in fraction form, a ratio is not the same as a fraction. For example, if we were to go back to our original example about the ratio of girls to boys. So a fraction would be if I took a pizza and I broke it into 3 parts, so each part was 1/3, and I ate 2 of those pieces, well then you would say that I ate 2/3. I ate 2 out of the 3 pieces. Well, this ratio is different because it's comparing not a part to a whole, which is what a fraction does. A fraction is all about part to whole. A ratio doesn't only compare part to whole. Ratios also compare part to part. So in this example, because there are 2 girls and 3 boys, we're not comparing the part to the whole. The whole would be all of the kids. So we're just comparing one part of the group to another part of the group. So a ratio is different from a fraction, even though we can write it in fraction form. So let's look at this example. So we're going to do some jelly bean ratios. So we're going to use this jar of jelly beans to work out the following questions. Now in your notes, it is in black and white, so you're going to have to just kind of bear with me. One thing that will help is if you actually kind of write the colors down. So let's look at our table. So on our first example, we want to write the ratio for each of the following jelly bean combinations. So this jelly bean is yellow, and you may want to in your notes write yellow underneath, and then this jelly bean here is green, and you may want to write the word green underneath since you can't actually see the colors in your notes. But we want to figure out the ratio of yellow jelly beans to green jelly beans. So the first thing we need to do is figure out how many yellow jelly beans we have. And because the yellow jelly bean came first in the statement, it has to come, that number has to come first in our ratio. So the order is very important. So I'm going to count how many yellow jelly beans I have, and I see that there are 5 of them. And then I want to count how many green jelly beans I have, and I see that there are 3 of them. So the ratio would be 5 to 3. And if you'll notice here, we can write it 3 different ways: word form, as a symbol, or in fraction form. The next one is green to red. So I want to compare the green jelly beans to the red jelly beans. So I first want to figure out how many green jelly beans I have. And as we saw in the last example, we have 3 green jelly beans. Then we want to see how many red jelly beans we have. And if we look at our jar again, we see that we have 4 red jelly beans. So the ratio would be 3 to 4. And again, we can write that in 3 different ways. But keep in mind, this is not 3/4. This is 3 to 4, meaning 3 green jelly beans for every 4 jelly beans. So it is a difference. And back to what I was saying about order, how order matters. So in this example, the green's coming first and the red is coming second. Well, here we want to compare the red to the green. So the red is going to come first and the green is going to come second. So that has to be reflected in our ratio. We have to show the number of red first and the number of green second. So now, instead of the ratio being 3 to 4, now the ratio is 4 to 3. So you want to make sure that whatever order the statement is in, that your ratio is in the same order. And we would say that these are all examples of part-to-part ratios because they are comparing part of one group part of the group to another part of the group. So we're comparing part of the jelly bean group to another part, or one color in the jelly bean group to another color. So this is a part-to-part ratio. So now what we want to do is we want to actually look at some part-to-whole ratios, or whole to part, meaning that we're going to be comparing part of the group to the total of the group. And this is where it actually is like a fraction because fractions are part to whole. So the first one is we want to compare the green jelly bean to all the jelly beans in the jar. So the first thing we want to do is see how many green jelly beans we have. So we count and we know we have 3 green jelly beans. Then the next step is to actually go in and count how many total jelly beans we have. And we have 14 total jelly beans. So the ratio would be 3 to 14. And we showed it in symbol form. So then this would be a part to whole because we're comparing the part of the group to the whole group. This ratio, we want to compare all the jelly beans to the red. So we actually want to look at the total first, which is 14, and then compare that to the number of red jelly beans we have, which is 4. So this ratio would be 14 to 4. And we would call this ratio a whole to part ratio because the whole group is coming first and then part of the group is coming second. So then this last example is yellow jelly beans to all the jelly beans. So there are 5 yellow jelly beans and then 14 total. So that ratio would be 5 to 14. So part to whole or whole to part is another form of a ratio. So now we can use ratios to help us solve problems. So if we look at example 2, we're going to use this to help us. We're going to use the ratio to help us figure out the cost for the golf balls. So this first ratio is that we're going to pay $3 for each golf ball that we buy. So that basically means for every 1 golf ball that we buy, we're going to pay $3. Well, if we buy 10 golf balls, then that means if we're paying $3 for every single one, then that means we would end up paying $30 for 10. So if we're paying $3 for 1, we're going to pay $30 for 10. And we would say that these are equivalent ratios. They're equal ratios. So now let's look at this second example. So this is that we're going to pay $10 for 5 golf balls. So for every 5 golf balls that you buy, you're going to pay $10. Well, again, if we buy 10 golf balls, that means this group of 5, we're going to pay $10. And then this group of 5, again, we're going to pay $10. So in total, for these 10 golf balls, we're going to pay a total of $20. So this ratio helped us figure out how much we were going to pay. So the ratio was that we get 5 golf balls for $10. So if we buy 10 golf balls, it's going to cost us $20. So this is our next example. There are 4 boys for every 3 girls in Mrs. Jones' 5th period class. So 4 boys for every 3 girls. So if we were to group them, we have 4 boys in every group and we'd have 3 girls in every group. So if there are 28 kids in Mrs. Jones's 5th period class, how many boys are in the class? So again, we're going to use this ratio, 4 boys for every 3 girls, to help us figure out how many boys are in this class if there's a total of 28 kids. And obviously, if we add the 4 boys here to the 3 girls, that only makes up 7. So this is just representing a representation of how we can kind of break the class into groups. So let's start with the ratio of boys to girls. And we know the ratio of boys to girls is 4 to 3. Then the next thing we want to look at is the ratio of boys to total kids. Because what they're telling us here is when they said there's 28 kids in Mrs. Jones' class, they're giving us the total and they're asking us about the number of boys. So we need to figure out, well, what is the ratio of boys to total kids? And we're going to use this ratio here, this first ratio of 4 boys for every 3 girls, to let us come up with a ratio of boys to total kids. So boys to total kids would be 4 to 7. So let's write that ratio as a fraction, and it can help us find an equivalent fraction to help us solve this problem. So we know that there are 4 boys and there's a total of 7 kids in that in that ratio. So what we want to do is we want to set up some equal ratios. Well, we know that the total kids that we're looking for are 28. There's 28 total kids in her class. Now we know there's 7 total kids in this group, but there's 28 total kids in the class. And we want to figure out, how do we get from 7 to 28 and then create an equal ratio? Well, to go from 7 to 28, we can simply multiply by 4. Well, if we multiply one part of the ratio by 4, then we simply need to multiply the other part of the ratio by 4, and then that will tell us the number of boys in Mrs. Jones' class. So we're going to take the 7, which is the total number of kids in every grouping, and we're going to multiply that by 4 to get the 28 total kids, which basically means there are 4 groups. And then we're going to do the same to the top number, the number of boys. We're going to multiply that also by 14, which means in her class there are 16 boys in Mrs. Jones' class. So then our last example for today is how to use a ratio table to solve ratios. So we're looking here and it says my lemonade has a ratio of 2 lemons to 3 cups of water. If I want to have 20 cups of lemonade, how many lemons do I need? So we want to look at the part of the recipe and the whole. Well, the part is the 2 lemons, and then the whole is the 5 total cups that it's going to make. Then we want to look at how many cups of lemonade am I trying to make, and I'm trying to make 20 cups of lemonade. So I want to figure out, well, how many lemons will I need for that? So I want to see, well, how did I get from the 5 to the 20? What did I do to get from 5 to 20? Well, I had to multiply by 4. So if I did that to one side of the table, then I have to do that exact same thing to the other side of the table. So if I multiply 2 by 4, then that means this side of the table has to be 8. So that means that there had to be 8 lemons, that we have to use 8 lemons to make 20 cups of lemonade. So the important thing to remember about ratios is that they are a comparison. Sometimes it's a part to part, sometimes it's a part to whole, and that ratios can be written in 3 different ways: a symbol, words, or in fraction form. That a ratio is not the same thing as a fraction, so try not to get those mixed up, and we can use ratios to help us solve other problems.